So for the first part of this bonding and structure unit, we basically recap GCSE. The first one is we're going to look at ionic bonding. Ionic bonding is between a metal and a non-metal. So the key thing is, if you're not sure what type of bonding you've got, is to look at your periodic table. And on your periodic table, you know you've got all your metals. You have like your little line that divides. Those are your non-metals there. You also have, you've got a little helium up there and hydrogen floating around, who's also a non-metal. But all of these guys are metals. So if you've got a compound which is these two combined, you know you've got an ionic bond between those. So what is an ionic bond? It's where an electron has been completely transferred from one atom to the next. So the simplest case is for sodium. So I only do the outer electrons because otherwise it gets quite boring, all the shells. In its outermost shell, sodium has got one electron, and in his outermost shell, chlorine has got 7 electrons. They both want full outer shells, and the easiest way to do that is for that electron, sodium, to go up to chlorine and go, whoa, you have my electron. Never draw, well you can draw this in the exam but then cross it out. What they're looking for in the exam is the final diagram. You put your ions in square brackets.
Always, any ion.
Yeah. So, what will be the charge on sodium? Lost an electron, he's going to be plus. Chloride now, he's got his 7 electrons that he had before, and he's gained sodium's electron, which I keep as a cross, so he is now going to be minus. And I formed an ionic bond.
Okay.
So an ionic bond is the electrostatic attraction between oppositely charged ions. So that's the simplest case of an ionic bond. If you did it that way in the exam, you would cross that out, because that's what you want marked. Sometimes it helps to do them before, but it's this final thing. So you can do slightly more complicated examples. So if you've got, say, magnesium, magnesium has got 2 electrons, and if I say you do chlorine again, he's got 7 electrons. Magnesium wants to get rid of both those electrons. One of those can go to there, but what does he need? He needs another. He needs another chlorine to come along.
Oh yeah, sorry.
And then that electron can go there. So I end up with it being Mg. Now Mg has lost 2 electrons. 2 plus. And chlorine, I'm going to have 2 of these, with each one with a minus charge. Like so. So as long as you do the basic ones, you're okay. Now you need to, obviously, the key thing is you can work out the formulae of these. Remember the group 1. So if you look at your periodic table, group 1 will always form +1 ions.
And it only needs one more thing.
He's only got 1 electron to lose. Group 2 is going to form +2 ions. Group 3 is going to form +3 ions. Group 4 does not ionically bond. Group 5, we've gone into the non-metals now.
Minus.
So he's going to be the 3 minus ions.
And then 2 minus.
Yep, 6, 2 minus, 7, 1 minus ions.
Yep.
So you've got to be able to, so you need to go to use your periodic table to do those. Because before you can really draw your ionic compound, like with the square brackets, you've got to be able to work out the formula. as well. So, for example, if they said, okay, what is the formula of, let's do aluminium bromide. So they said, right, aluminium
Group 3.
bromide. So, yeah, aluminium is in group 3. So he's going to form Al3 plus.
And then Br's group 7, so minus 1, so you need 3 bromine.
Brilliant, yeah. So it's AlBr3.
Yeah.
That's it. Because you've got to have your charges cancelled. What you have to learn is you've got to learn your more complicated ions that they won't give you. So the ones you've got to know at AS, you've got to know the sulfate is SO4 2 minus, nitrate NO3 minus, carbonate CO3 2 minus, ammonium is NH4 plus, and hydroxide is OH minus. Now to do the formula, for these guys you have to be able to use brackets. So let's say they asked you now for the formula of calcium nitrate.
So it's group 2.
Yep, so calcium is Ca2 plus.
2 plus, and then nitrate is 3 minus, comes in 5.
Nitrate, no, it's nitrate, remember, not nitride.
Oh, okay.
Nitrate is,
NO3 minus.
yep. How many, I've got to get the same number of pluses as
You
minuses.
want 2, you want bracket around the NO3, and then
Yeah.
2 on the
Fantastic.
left, little 2.
So that's it there. So you've got to get them to match up.
Yeah.
But as long as you can do that, you're fine. So you've got to watch. If I said calcium nitride, nitride is when it would be Ca2 plus and N3 minus,
Yeah.
nitride and nitrogen. So the formula in that case, how would I do that?
You'd want 3 of the Ca2 plus.
Yep, C and 2.
And then 2 of the second one.
Yeah, that's right, yeah. So it would work like that, so that'd be calcium nitrate. So you've got to watch what they're doing. So when you're doing like acid, because these guys you get from sulfuric acid, nitric acid,
Yeah, okay.
yeah, ammonia. So these ones, whenever it's acids, you're looking around these, so with
Yeah.
salts and stuff like that. But for these, you've got to be able to work out the formula as well. So that's the bonding. The other thing is they want you to talk about is what is the structure of ionic. So that's the bonding, but they also like you to think about the structure. So ionic substances, let's call them compounds, they have a giant ionic structure. Giant ionic. So this is the giant ionic structure of sodium chloride. So you've got your, well, we'll call the green chlorine, and then these are the sodium. And so rather than, you know, when we talk about covalent things, we just talk about molecules with discrete things. This is a giant structure because everyone is bonded in, you know, you can see the bonds. So these are all the attractions between it. So if I have salt, sodium chloride, they're all interconnected. It's a giant structure on a massive scale. To be able to draw that, very rarely they ask you to do it in 3D. Normally the key thing is you have an Na plus and a Cl minus. Surrounding the Na pluses are always Cl, so you go alternate.
Okay.
You would never have two Na pluses.
So it's always a diagonal line.
Yeah, so they always go like that. So if I had to do it in 3D, which would be a disaster for me, but going down there would be a Cl minus, but then across there would be an Na plus, that would be a Cl minus, like so, and then going off behind, this would have to be a Cl minus, Na plus going down, that's going to be Cl minus, and then Na plus would be N closer. So that's the key thing. It's a giant structure where they're all interconnected, and ionic bonds are really strong. So they're always solid at room temperature. And they always have very high melting and boiling points. They have high melting points and boiling points because you have to break strong ionic bonds. Because you're breaking strong ionic bonds. Will they conduct electricity? Well, in a solid state, you need a charge carrier to conduct electricity. So although I've got ions that are charged, in a solid they're trapped, they can't move. But if I was to dissolve this in water, or it's molten, I can do. So they do not conduct electricity, do not conduct a solid. When solid. But they do conduct when dissolved or molten. Because they have charge carriers that can move. And they can't move when they're solid. So the key thing is in an answer, they don't conduct when solid, but they do conduct when dissolved, because that's when the charge carriers can move. In the solid, they're trapped, they can't move. And that is pretty much what there is to ionic bonding.